Hello guys. So today we have a topic application of derivatives, Rolle's theorem, and this is part 3. So in the previous lectures we discussed the Rolle's theorem. So according to Rolle's theorem we have a function, any type of function, trigger function, log function, exponential function, inverse function, any one. And one more thing, you have an interval. So according to this, we want to verify the Rolle's theorem on this function at this given interval. So for verification of this Rolle's theorem, we have three conditions. So number one is this given function, this should be continuous at close interval a comma b. Second condition, derivative of this function should exist between a and b except these terminal values. So fx will be differentiable at close interval. This is the big difference between this and this point. So there is a close interval, but right now you have open interval. And the third condition is this: we place these values a and b in this function and collect fa and fb. And situation is this: these should be equal. If this is equal and this is continuous and this is differentiable, means all the three conditions are satisfied. It means there should be a value c, maybe fractional value, maybe irrational value, maybe integral value, decimal value, but it should lie between a and b, on which the condition, the first derivative, should be equal to 0. So for any value which lie between a and b, so for this value c, the first derivative of the given function should be 0. So that value which lie between a and b, on this value the Rolle's theorem will be verified. Okay, so this is the scenario. According to this, we will verify Rolle's theorem on this function for this interval. First, we will state that given function is continuous at close interval. Second statement, the function is differentiable at open interval. Third, we will show fa equals to fb, means the value of function on these terminal values should be equal. If all the three conditions, above conditions, are satisfied, proved, then there should be some value c on which the first derivative of the function should be 0. For that value which lie between a and b, Rolle's theorem will be verified. So this is the working rule. The given function fx is x into x plus 2, and these are multiplied with e to the power x, and the interval is -2, 0, close interval. So first we will write first statement, the function fx is differentiable. For the verification, there is no need to prove this. The first statement is this: the function is continuous at close interval -2, 0. And similarly, we will state the function fx is differentiable at open interval -2, 0. And third one, this should be proved. So we will place these values in the function, like we will take the first value -2. So f -2, the value of function at -2 is -2 -2 plus 2 e to the power 2. So this is -2 and +2, this becomes 0. On multiply with this, finally you will get 0. And so the second value f0 on second terminal, so again multiply with 0, result will be 0. That shows f -2 is f0. So all the three conditions are satisfied. There should be a value c between a and b at which f dash c will be 0. So the first derivative of the function will be x plus 2 e to the power x. We can write x square plus 2x e to the power x. So the first derivative that will be f dash x. This is a given function. So now on differentiation we get, first we differentiate the first part, so it will be 2x plus 2 and e to the power x as it is. We are using product formula. So now the first function as it is, and the derivative of e to the power x is e to the power x. So on taking common e to the power x, we get x square plus 2x plus 2x, that is 4x plus 2. So this is f dash x. So we have f dash x is e to the power x, x square plus 4x plus 2. So on putting value x as c, so we get f dash c will be e to the power c, c square plus 4c plus 2, and this should be 0. E to the power c can't be 0. It means c square plus 4c plus 2 is 0. So on using the quadratic formula, c equals to -4 plus minus under root 4 square minus 4 into 1 into 2 divided by 2 into 1. So it is -2 plus minus, this is 16 minus 8, so you get 8 over 2, that is -4 plus minus 2 root 2 over 2. So you get minus 2 plus minus root 2. The value of root 2 is 1.414. So when you take positive sign, then it will be minus 2 plus 1.414 and minus 2 minus 1.414. This is greater than the our interval, so this can't be possible. So it is the intermediate value. So on this value you have minus 2 greater than it is minus 2 plus root 2. So on this value, which lie between minus 2 and 0, the given function is verified for Rolle's theorem. So Rolle's theorem is verified at this value. Fx equals to sin x minus sin 2x, and interval is 0 to 2 pi. So sine functions are continuous functions. That's why the first statement we can write easily: fx is continuous at close interval 0 to 2 pi. And second statement, again this is differentiable on each value between 0 to 2 pi. And third is we will place these values, terminal values, in this function. So f0 is sine 0 minus sine into, so sine 0, these are 0, and f2 pi is sine 2 pi minus sine 4 pi. So again these values are 0. So f0 equals to f2 pi. So all the three conditions again we can say are satisfied. That means there should be some value c for which the first derivative will be 0. So we collect the first derivative f dash x, that is on differentiation of sin x is cos x, and differentiation of sin 2x will be 2 cos 2x. So it will be, now f dash c will be cos c minus 2 cos 2c, and this should be 0. We will use this, and you can place the value of cos 2c as 2 cos square c minus 1. So it will be cos c minus twice of 2 cos square c minus 1. So you get on other side this becomes 4 cos square c, and this becomes minus cos c and minus 2. So this is a quadratic equation. You can consider, you can let cos c as p. So this becomes 4p square minus p minus 2 equals to 0. So on using quadratic formula, we get 4p square minus p minus 2 equals to 0. It means p will be minus of minus 1 plus minus under root minus 1 square minus 4 into minus 2 divided by 2 into 4. So you get 1 plus minus, it is 1, and this is 16, and 33 is the total over 8. So the root of 25 is 5 and root of 36 is 6, and it is in between, so it will be 5.5 or 5.6 around. So when you add this one, you get 6.6 divided is 0.8 around, so it will be between the interval 0 to 2 pi. And when this is we will take negative sign, that it will be outside the range. So C will be so the Rolle's theorem is verified. Now the next question, that is the important question. So it is, at what points on the curve y equals to cos x minus 1 in this interval is the tangent parallel to the x-axis? So we want to collect the points on the curve, this curve, where the tangent on this curve parallel to x-axis. So what is the concept of tangent? If you have any line which makes angle theta with positive x-axis, then the slope will be tan theta, that is dy by dx, or you can say this is the first derivative. So first derivative is tan theta. So if we have a curve and we have tangent means the slope. So the slope of this is with a positive x-axis. If it is parallel to this, then angle will be 0. So tan theta is tan 0. So f dash x is tan theta is 0, so f dash x is 0. So this is a concept we will use this. So according to this is similar to Rolle's theorem. So we will use the Rolle's theorem. According to this theorem, being a cos function, so it will be continuous at 0 to 2 pi. And second, the given function is differentiable, because a cos function is differentiable between this interval. And the third point is this, we will place these values in this function. So when you place 0, so f0 is cos 0 minus 1, cos 0 is 1, so 1 minus 1 is 0. And when you place 2 pi in this function, so cos 2 pi minus 1, and cos 2 pi is again 1, 1 minus 1 is 0. So both the values are equal on this function. So right now, according to this concept, f dash c is 0, because tangent parallel to x-axis, theta is 0, so tan theta is 0, so the derivative is 0. So we will differentiate this. So cos x derivative is minus sin x, so we will minus sin c equals to 0. So sin c is 0. So sin c is 0, it means according to this interval, this can be 0, pi and 2 pi. But we want the value between 0 and 2 pi, not the terminal values. So these are rejected. So this is the only value of c on which the Rolle's theorem is verified.